morning, and indeed welcome to the session focusing on key enabling technologies and how they can enable CCAM. We will be discussing their progressive development and maturation towards addressing needs and demands also put forward by different types of users and by society. And we will also discuss how we can benefit from developments in other sectors. So expectations are high, I think, but also vice versa. What can other sectors learn from us? And how the integration of key enabling technologies can bring advantages towards, for instance, the software-defined vehicle, energy efficiency, integration of CCAM vehicles into the mobility system, and we hope to gain some further insights in approaches to ensure that societal needs are addressed while going along these developments. I say we because, of course, I'm not standing here all by myself. And if you can click so we can get the names on the screen, that would be helpful. That's, of course,
the remote session. The clicker, it's not working anymore. No,
yeah. Oh, it does magically. First of all, we have Oyana Otaegi from EARPA, board member, and also Director of Transport and the Security Division at Vicomtech. We have Georg Stettinger, Senior Project Manager at Infineon. And then we also have Selim Solnas, Head of Control Systems Group at Virtual Vehicle. And we have Sven Bijker, External Advisor to SAE International. And my co-moderator here on my left hand, for you on my right, is Gerian Meyer, Head of Department of European and International Business Development at VDI-VDE. And my name is Margriet van Schijndel. I'm Program Director Responsible Mobility at Eindhoven University of Technology. We also have the luxury of, as we expect, we have high expectations. So we have the luxury and I guess the need for two rapporteurs who are Helene Correale and David Storer from CLEPA in the middle of the room. The setup of this session is that we have 4 short introduction statements by the 4 speakers. And then we'll have a discussion with the panel on most of them on prepared questions, but of course there need to be some surprises. And we can imagine that we didn't come up with all the questions that you may have, so we have a short Q&A with you foreseen. And we hope that the speakers are not going to ruin that schedule. We'll just see. I would say, ready to go? Yeah? To see if you're really here with us, we start with the Mentimeter question to you as audience. So now you are allowed to grab your phone and go to Menti. And we ask you which key enabling technologies, also from other sectors, can be relevant to really progress and innovate in CCAM. I'm not sure the remote operation is going to be one of them because this is a bit a hard one. We understand you need a bit time to make the scan and to do the thinking, most probably. I think that might be taking more time than just the scanning. You have some time to answer the question because we will look into the results after we've had the opening statements. So if you feel like I filled in something, but I need to add something based on the inputs from the speakers, then you do have the opportunity to do so. So after the last speaker, we go into the results. And having said that, I think it's time for us to kick off. And Oyana, you can come to the stage.
Hopefully it works.
Thank you. So,
can we bring the presentation back? Thank you.
Okay. Let's see. Presentation mode. Okay. Okay. So, first of all, thank you for inviting me to this panel. And today, let me say that I'm wearing 3 hats. I'm representing research. As Margaret mentioned, I'm working on research institution and also representing EARPA as Automotive Research Association. I'm representing ATRA regarding the key enabling technologies, and also CCAM partnership. So to begin this statement, I would like to go through the evolution of the key enabling technologies in CCAM. So going a little bit back, when we have the first strategic research agenda in 2016, there was no mention of key enabling technologies, only a very vague reflecting on AI as a potential future. Going back to the 2018, with the update of the research and innovation agenda, there were a statement that AI and data could be future technologies for somehow making emphasis on in-vehicle technologies, and that could accelerate the industry. Today, in the CCAM partnership, sorry if this works. Okay. So we have a strategic framework where the key enabling technology and AI is firmly established. We do have a dedicated cluster for seeing how can we integrate those key enabling technologies in the full value chain. Okay. So today, I would really like to emphasize on how difficult or how we have been handling this integration of key enabling technologies. And for that, I want to emphasize three main pillars. The first one is that for integrating those key enabling technologies, we really need a sectorial adoption of the technologies, which means that we can have technology that is horizontal, not sectorial. But then if we want to apply that to specific sectors where we do have some kind of limitation and requirements, we need to adapt that. And we see here today in the EUCAD that there are projects like Selfie or Itena that are doing this exercise. On the other side, we also can use these key enabling technologies for testing and validation. So we need to take into account that in the automotive, we need to ensure that the system is working in no deterministic situation. So trying to bring new technologies to ensure that is especially relevant, and we can see Sunrise Synergies project trying to deal with that. And finally, these key enabling technologies are also enabling the physical and digital infrastructure for enabling this connectivity, which is also key. So what we see is that we need really to build, to make these building blocks to ensure that we can adapt the technology, but not only the technology, we need to adapt the technology to specific requirements of the sectors, like regulatory, collaborative, or institutional requirements. And this brings to my final part of my statement, where I wanted to emphasize how complex ecosystem we have if we want to bring the key enabling technologies into a vertical sector. So we do have these horizontal activities that they are developing these key enabling technologies, but we do have automotive sectors as a vertical and very demanding one. So there is a gap that we need to close. And for closing this gap, it's not going to be done by a sector or an enterprise or industry alone. So we need ecosystem, we need shared interfaces, we need to build common foundation, like in software-defined vehicles, not to invest in dozens of LLMs. So we need to have one foundation, and on base of that, we need to go sectorial. And we need not to forget that the resources are limited, and the collaboration is a key element if we want to bring the tier levels of promising technologies into large-scale demonstration. Thank you.
Thank you, Oyana. Could you stay for a second? Because I do have a quick question. I do have a quick question to you. I mean, what you're describing here in particular, what we see in software-defined vehicle being a quite sophisticated concept and a new one that's fundamentally changing how the vehicle control system will be built. I mean, that's the tech side in it. It's super exciting. That's probably the reason why we have all the people here being interested in it. And at the same time, we are also looking a bit into the human and societal dimension in this session. Do you have a good reason for somebody who is asking, from a user perspective, what's the added benefit of this? Could you tell a bit what changes from a user's perspective if, for example, we turn to software-defined vehicles in CCAM?
So from the user perspective, the technology approach is somehow not evident. But if we are using this kind of approaches, what we are going to have is easier, more flexible, and more adaptive possibilities of bringing the requirements into the building of the solution. So I think that this concept enables to be more reactive and more flexible to what the society is demanding, and being flexible to integrate them and to bring them to the market.
So to my understanding, it provides users with a smarter experience,
Yes.
in a sense, a more, a leaner experience,
Yes.
things like that, more comfortable experience. Thank you, Jana.
Thank
we will
you.
be discussing with the audience later, but let's maybe turn a bit deeper into the technology domain, in particular this topic of software-defined vehicle. And for that, I would like to hand over to Georg Stettinger. Georg is a senior project manager with the computer chip maker Infineon in Munich, and he is coordinating, by the way, a new project that is addressing the 2024 Cluster 2 call. But I believe this will be starting later this year, and you will be saying something a bit more fundamental on the topic of software-defined vehicles. So let's try to get your presentation running. There it is. Yeah, over to Georg.
Thanks a lot, Gerian, for the introduction. It's a pleasure for me to be here. My name is Georg Stettinger. I'm representing the semiconductor industry in that panel, and I'm active in electronics, of course, and artificial intelligence. I have a long journey in coordinating and managing projects in Horizon Europe in the CHIPS JU world, formerly KDT JU, Excel JU. It changed several times, and now I'm also very active in the CCAM community. As Gerian mentioned, I'm coordinating an upcoming project starting 1st of June, dealing with the future EE architectures of software-defined vehicles. But what I want to tell you today is, I have just one slide. It looks very complicated, but let's pick out the most important messages for me to stimulate the discussion. When we take a look now at software-defined vehicles, we have many components already in place. We have radars, we have cameras, we have lidars, we have computing power. We have, from all the components necessary, the version 0 available, I would say. And what is the next logical step in making them better, more affordable, more energy efficient? We have the very, I would say, exciting challenge on our table. We have to make things better in terms of performance, and in parallel also in terms of energy efficiency. That's a quite logical consequence in the next iteration of making products, because we, at the end of the day, want to make it as efficient as possible. We want to reduce the costs and also improve affordability there. So that's a huge challenge, performance increasement, and in parallel, more energy efficient. That's, by the way, one of our biggest challenges, not just in automotive for semiconductor, but across all sectors. We always want to do better with less power. On the other hand, artificial intelligence is a big driving force on our side, and this also changes a lot the thinking also in our company. And when we started, we analyzed, okay, what is now different? Let's take a look on the life cycle. That's the picture in the center. And there are so many players available, and all have to work together that we can realize those products. I just mentioned a few of them. So in the yellow font, you can see many different fields where engineers are working from different domains. In the blue fields, you can see the activities or the tasks which has to happen in the life cycle. And only if this works together with clearly defined interfaces, we can make the excellent products out of it. And that's, by definition, a huge challenge. And therefore, I wrote here, or I put the life cycle in the center, also for another reason, not just the challenge of integrating all those players efficiently, but in the last years and in the last discussions, there is always the thinking, okay, we have hardware-software co-design and we have hardware-software decoupling. And I was always thinking, how can this fit together? Looks like there are two different approaches, two different fields, but when we take a look at the life cycle, we can bring them together. We can say, okay, let's focus on hardware software co-design in the first part until we deploy the products. Why do we have to do this? Because of the first challenge. If we don't do hardware software co-design, we cannot improve the performance and reduce energy efficiency simultaneously. We have to make use of hardware software co-design. And when we then deploy it, then we are ready for software-defined products, not just vehicles. Then we have to do the decoupling, because after the deployment, we all know software is very fast. Hardware development takes a long time. So afterwards, we have to do the decoupling. And from my perspective, let's discuss it with you. The life cycle is a good element to bring both worlds together. Thanks a lot.
Yeah, thank you very much, Georg. Also here, a quick question, and thank you for explaining this concept and this kind of obvious contradiction of the two parts in it, the decoupling on the one hand and the co-design, which means like to merge and interrelate at the same time. Coming back a bit to this perspective that we had with the users before when discussing Oyana's intervention, could we compare a future car with a smartphone in a sense, where obviously we have a decoupling between software and hardware, or is it something else?
Good question. I think so, yes. So I think so, definitely. Not just the car, but many other products. But we have to think about how often do we really need an update, especially a safety critical one. So if it's entertainment, I think we can take over lots of concepts and new features and updates and stuff like this. But when it affects also safety critical functions, I think we should be more careful and really have a clear process, safe one available, that we know what will happen when we do the update.
So it's not a smartphone on wheels, but something more sophisticated, particularly if it comes to safety, as you're saying. And I guess also energy efficiency, right?
Yes.
All right. Thank you, Georg. And let's continue with our brief lineup of our speakers with a view a little bit further downstream. And we are having Selim Solmaz here, who is the lead researcher on autonomous driving technologies with the Virtual Vehicle Research Center in Graz in Austria. And Selim will be talking a bit about validation and verification. So the next steps after we have started to develop new tech. Yeah. Selim.
Thank you very much, Jeroen. So, good morning from my side. My name is Selim Solmaz. I'm with Virtual Vehicle. Virtual Vehicle, if you don't know, is a research technology organization located in Graz, Austria. So we place ourselves exactly in between industry and academia as a research technology organization. And I will try to give in this talk about my view on validation and verification in the context of CCAM systems of the future. So let me also mention that it's a pleasure to be part of this elite panel, and I would like to thank Jeroen and Margaret for the nice invitation. Thank you. So, right, so the focus in my opening is the critical role of validation and verification of CCAM systems, particularly drawing the insights from other sectors. Yeah. So, the starting point, so if you look at this onion chart, so we know that for safe and successful adoption of CCAM systems, rigorous validation and verification is a must. So, given the fact that CCAM systems evolve thanks to new projects and also immense interest from the industry and also the end users and the society, we also need to think about how we can adapt our validation and verification strategies, as we all know that traditional approaches for automated driving systems to start with is not the same, right, as the traditional automotive validation and verification. So, in doing so, actually, we are also looking into learning from other sectors and cross-sectoral collaboration. And in this context, we have already heard some other partnerships like ARDA and CHIPS.JU, which I think are quite relevant. So the idea is to leverage cross-sectoral innovations, for example, in electronics, robotics, and aerospace, and as well as software, to enhance CCAM validation and verification methodologies. Thereby, then we adapt proven testing strategies or validation strategies to accelerate development to ensure robustness. So, given the key enabling technologies, European key enabling technologies, also developed in parallel, how we can see the CCAM priorities taking into these developments in key enabling technologies from the perspective of validation and verification. So I can name a few examples. We have already heard the mentioning of software-defined vehicles and centralized architectures. So we can consider new validation and verification approaches for dynamic updatable systems, because new vehicles, new CCAM systems get continuous updates, and we need to find answers, reliable, robust answers and solutions to ensure that the systems are safe and secure, right? So we need to then also take into account the validation and verification approaches in this. So there's the question of system level integration, where validating interactions of not only the vehicle itself and in-vehicle technologies, but the vehicle as part of the traffic and mobility system with the infrastructure, digital and physical, as well as its interactions with data spaces and AI, is a question for validation and verification. We know that so every engineering system is trying to be more efficient and sustainable, and we can also think the same from validation and verification perspective. So we also need to take into account during the testing procedures these aspects of energy efficiency and sustainability. And finally, I can mention the user trust. So end users need to trust the developed systems, and we need to demonstrate safety and reliability through our validation and verification approaches for such systems. In the end, all this boils down to meeting the societal demands. Ensuring CCAM systems are safe, reliable, certifiable, upgradable, and cyber secure is of paramount importance. So validation and verification methodologies must therefore evolve along with the systems to keep up with this rapid technological investments to align with the societal values, safety requirements, and sustainability goals. So what I see as the path forward is a collaborative effort to build and adapt the validation verification frameworks that ensure trustworthy and beneficial CCAM for all. And with this, I would like to conclude my speech here. Thank you.
Thank you, Selim. Very nice introduction to this part as well. I was wondering, you talk about V&V need to evolve to be in line with the technological developments. And we talk later also about, can we use key enabling technologies from other sectors? If we do so, do we need to take other actors on board in our validation and verification processes?
A simple answer is yes. The bigger answer, or more difficult question in this is how. This needs to be, of course, defined. But yes, definitely, we have to do it, I would say. Actually, if we want to be a good competitor for the international competition as Europe, I think not in automotive sector alone, we also need to think about collaboration across all the sectors within Europe.
Thank you. Yeah. Thank you, Selim. Thank you. Thank you for that answer. With still some uncertainties, but I think that's something that we'll find out along the way. But also thank you for opening the door to look beyond Europe, because Sven, I think that's the area where you're working also in other regions. So welcome for your opening statement.
Great. Thanks very much for the introduction and the invitation to be here on this panel. Well, Sven Biker, I'm here in my role as the SAE International Representative on the US West Coast in Silicon Valley and beyond. And I'm also the chairman of the SAE Europe Advisory Board, so that straddles already a couple of regions. And I'm also very happy to talk here about regional perspectives, given that I started my career as a German automotive engineer and was transferred into Silicon Valley now about 22 years ago. And these days, I am really happy to work also quite a bit in academia in Sweden. I interact with UNECE in Geneva, Switzerland, and obviously I like to be connected here to the European community as we have this panel here today. So I was asked to talk a little bit about regional perspectives regarding CCAM. And one thing that I wanted to point out here on the left is the word CCAM is not really well known in the US. And Jane and I, we can have a discussion whether there's a difference between the East Coast and the West Coast. But if you were to ask people in Silicon Valley what they think about CCAM, they would probably first ask like the favorite generative AI thing, what is CCAM? But they don't know the term. They know, as you see there, CAV, so connected and automated vehicles, but the cooperative part in it, they don't really see so much. They really see an automated or autonomous vehicle, for that matter, as something that is standalone. So that's something to keep in mind as we're having these discussions here. There are obviously regional differences, which why I was invited to talk about those. In Europe, to my knowledge, CCAM obviously is front and center. People know, those people who work in the field, they certainly know what's being talked about. In China, as much as I know, I don't claim to be a China expert, but the term is known in China also relatively well. But they talk a lot about intelligent and connected vehicles, as you see there at the very right. So that's a distinction that you want to keep in mind when discussing with peers across different regions, that it's like tomatoes and tomatoes. You might be talking about the same thing, but there's different terminologies. So therefore, the second bullet point in each of the rows, in my perception, in the United States, it's really a lot about independent and decentralized technology. So you want to build the smartest vehicle possible. And then it almost comes a little bit a competition, who has the smartest vehicle on the road, where my slide went away, but I think in the middle, I basically say in Europe, we are taking a much more cooperative approach. And I say we because I really identify with this quite a bit. And I think that is really important because, as I always like to point out, we are not working on the next generation of vehicles. We are not working on automobile 2.0. We are really talking about a new way how we organize traffic, transportation, and mobility. And as such, it's only so much if you have a very smart vehicle on the road. It is really much more about this cooperative and integrative approach that you see there under Europe as the second bullet point. In China, to my knowledge, and as much as I'm discussing with people and when I go there and visit, and my impression is, it's a lot about scalability, to really have innovation that you can scale very, very quickly. In the United States, and the third row, the third bullet point, is about creating new businesses. Disruption, an overused term, but still it typically fires off your neurons and you think the right thing. This is about changing everything and create a new business and really turn this into something. Whereas in Europe, it's much more about how can we benefit the society. And this is why I was really honored and excited to be on this panel here as well, to really talk about how enabling technologies in the end can be put to use for the benefit of society and how we can address the real problems that we have, in addition to hopefully creating good businesses as well. In China, my impression, it's about improving transportation, obviously with a very, very large population and all these mega cities, how do you move people around? The enabling technologies, as much as I observe them in the United States, the bottom row of those bullets, artificial intelligence, obviously sensors and also simulation. We just heard about testing, validation, and verification. So really these simulation models are a pretty big deal in Silicon Valley and beyond. How do you actually virtualize what the vehicle is going to be doing in the real world afterwards. In Europe, I observe a lot about work on infrastructure that I really appreciate, that I really applaud, because again, it's not just about the smartest vehicle, it's really how we integrate all of those and what is the enabling infrastructure that we need for those. And if the slide were still up there, then in the bottom right corner for China, you would see the enabling technologies are a lot really about the features and how you can build a good value proposition for the consumers. So there are really these nuances. They're all talking about the same thing, tomatoes and tomatoes, but definitely not always the same goals. And the enabling technologies, I'm sure we're going to discuss a little bit further in our panel. Thank you.
Sven, please stay. We need to talk things. Yeah. So first,
was it not good? We have
no,
to
no,
talk?
it was perfect, and we have done these kinds of analysis.
Sounds
in
like the head
past, and-
teacher wants to talk to me.
Sven, look, many things coming from the US these days makes us shudder here in Europe, and probably also many people in the US. But maybe let's talk Tesla.
Okay, I was like,
Okay,
well,
let's
that
talk
is
that.
close enough. To what
Okay,
I was,
okay.
like,
So
scared you might ask me now.
that's the column on the
Don't
left.
ask me
Okay,
to
that's
explain the president.
Please, no. A few days ago, NHTSA, the U.S. Road Safety Administration, Traffic Safety Administration, raised a number of questions about the safety of the Tesla robotaxi system that the company is about to deploy in Austin, Texas, I think, in June,
Yes,
correct?
in June,
It's
just
a
next month.
I was surprised by this long list of questions on technical matters and how they prove and know that the system is really safe and so on. To my understanding, it's just cameras, probably very good cameras, and a lot of them in combination with AI. Will this work? What's what do you think? Will it be safe, or is it safe? Will it be safe in the future? Or does it require that we all adjust our perception of safety to maybe, as we have adjusted it to the perception of truth after knowing and working with ChatGPT and knowing that it's hallucinating once in a while? So, Sven.
Well, let's see. Will it be safe? I would assume that it will live up to the safety standard that the maker of these vehicles sees as a safety standard. And there there we have seen obviously that safety lies in the eye of the beholder, but it should not be an opinion. It should be factual. And me as an engineer, I for now would say really take the three primary sensors that are available, which is beyond cameras, obviously LiDAR and radar technology. I don't really see why you would not use them. And still, this time I do expect that we will see a cyber cap or whatever it will be called then. They're even trying to trademark, I think, these terms now at this company that you mentioned. And I think this time we will see something there on the roads. It will not be, in my expectation, it will not be a copy of a Waymo vehicle or like a Pony AI vehicle or WeRide or Baidu or what Cruise used to have. It will be a Tesla interpretation of what we discussed as a robotaxi. I do expect, let me say, hiccups here and there. Hopefully not tragic. And the community will learn from it. And we will learn a better answer to your question than the one that I can give you at this point, how far we can get with cameras and AI. As an engineer, I do subscribe to the notion that in principle, it might be enough, but I think overall the systems are not there yet that it is enough today.
Probably depends a lot on further development of AI, which is,
of course,
developing rapidly these days.
Absolutely.
Sven, thank you so much.
Welcome.
And, looking forward to this discussion. Handing over to Marieke.
Thank you. I guess we're all by now, apart from those who just entered and didn't know what the question in the Mentimeter was, we're all curious about the results on which key enabling technologies would be helpful for CCAM. So I hope that the magic works. And this is the word cloud that you have been working on this morning. V2X, AI, connectivity, virtual test platform, teleoperation, money as a key enabling technology. Maybe I should skip the word technology there. It's definitely a key enabler here. Mind uploading. So I see that the panel members are intrigued by some of the answers. I think that's good to see. Cybersecurity, edge computing, artificial intelligence and AI. So your first responses from the panel on the inputs from the audience. Some nodding. Selim, are you willing to speak?
From my perspective, yes, they are quite relevant. AI and V2X are very, very important for CCAM systems. So yeah, as expected.
Okay, good. Sven.
I also appreciate, for instance, that there's social science in there. So really the interdisciplinary approach, I think is really important, as I just said in my remarks. So this is about really integrating like the latest and greatest technology into traffic as we know it. And that is by far not just a technology question that goes beyond obviously legal aspects and so on as well, but the social science, I really appreciate. Whoever put it in there, you get 100 points.
I think there were at least two people thinking a bit in the same direction, because we also have societal economy, which need to be connected there as well. Good. Thank you so far. So I think you're warmed up and you put some challenges, but we'll see what happens with the next questions and your answers to that.
You can.
You're not sealing the microphone? Okay, good. I think it's also good to hear from you as panel members where you think that are useful sources for future key enabling technologies or short-term key enabling technologies that we can take on board within CCAM. And I start with you, Oyana.
Yeah, so going to your question from where, so we can see here that the key enabling technologies that at least we here in Europe see are a combination of what we were mentioning, so technology for society, which means that we need to be clear on selecting proper key enabling technologies, see their potential. And what for me is more important is also to ensure the maturity or how to bring these promising technologies into a maturity level where we can integrate safely into the system. So it's not only about identifying, it's also about how we make the proper path to ensure the integration of those key enabling technologies into this demanding sector, which is the mobility, taking into account that we need to take those technologies that are also, or that will help or be beneficial for societal benefit. It's not like only choosing and using a key enabling technology because it's a hype or because it could be very nice from an engineering perspective.
Thank you. And a bit also aligned already with some of the inputs we've seen. I think, Selim, you also touched a bit on getting input from other sectors. Can you elaborate a bit on that as well?
Yeah, actually, we see this also in this response. There are actually several mentioning of communication. So if you look at V2X, CITS, 5G V2X. So I think this is one of the primary influences on the CCAM system. So I think in the CCAM system solution of the future, this is an unavoidable element. But we also see the fact that CCAM systems and automated vehicles in it are actually very sophisticated robots driving in a very complex environment. So we can see that other fields such as robotics, software, communication can be considered in this context, and methods, solutions, validation, verification approaches from these fields can benefit from or can be transferred potentially to also CCAM context.
Thank you.
You're welcome.
I see your neighbor neighbors either disagreeing or fully agreeing. What do you think?
No, the neighbor's adding to it. And it's especially adding to the discussion that we had during the presentation from Georg as well, when the question from Gerion was, what about a smartphone on the wheels or something like this? And this is really where I encourage everybody to look beyond like our beloved electronic devices and not ask the question, what if my car was as smart as my smartphone or my mobile phone? Or to ask the question, what if my car was as smart as a tractor that a farmer uses on his or her field? And that's something that we quite often overlook. And that's what I appreciate through my work with SAE, that does not only touch actually road vehicles, but also commercial vehicles such as agricultural equipment, mining equipment, all these things, and airplanes, aircrafts as well. So we have a lot of technology already in other vehicle sectors, such as tractors and excavators and mining equipment and all of this. And many of those are already driverless. Many of those are already connected. Many of those are already like fully predictive maintenance enabled and something like this. So we don't need to look always at our phones and hope for the answers. Sometimes it's on the field with a farmer.
I like this a lot. And there is a part in it that that's directly triggering my next question, if I may, Marie. The point is we with many of the things that we see here, whether that's edge computing, quantum sensors, software-defined vehicles, cloud intelligence. I mean, this is all very sophisticated technology, yeah? And certainly it will add to the performance of the vehicles, the smartness and things we have just discussed. But my question would be, what is good enough? So is there anything, any particular trend, any particular key technologies where we would say, well, this can contribute to safety, it can contribute to cost reduction, it can contribute to smart usage, and can also contribute to wider deployment? Is there anything like this as well? I don't see it really in this list, so I'm giving this back to Sven at first.
Well, I just said something. I was hoping you pick someone else, but now that you picked me.
I'll do that
well,
in a
okay,
second.
Okay, let's see. If you ask what is good enough, I mean, it almost brings up that question, how safe is safe enough? And you asked me earlier in your follow-up question to my opening remarks, are maybe just optical sensors, so cameras and AI, good enough to drive a vehicle by itself? So we don't know yet. And same as we don't have an answer like safe or what is safe enough. We don't really have an answer today, what is good enough. I personally believe it will not work without AI. So for the longest time, I need to say, as an automotive engineer, mechanical engineer by training, who I am, I thought, well, AI in an automobile, that's really tough with explainable AI, and if you need to defend your product in court, and the answer is, I don't really know why this happened, what happened, it's not a great answer. But I think AI is really table stakes, it will not work without. Other than that, I think the community of researchers, developers, regulators, operators have to experiment really with everything that is here on the list, and hopefully in a decade or two, we will know much more what is good enough. But since we don't really know exactly what we are aiming at, are we aiming at personally owned self-driving vehicles that can go from here just to Milan or all the way down to Sicily or to Norway or whatever? Or are we aiming at something that gets us here without a driver to the parking lot down in Ispra? That's a very different proposition. So I think we have to experiment more with it.
Maybe same question to Georg, because I mean, you are from an industry that has been driven for decades by making things better, smaller, less energy consumption. It's consuming some KPIs like hell. Is there anything you would say, well, in order to keep up with our competitors, for example, from China, it would make sense to also consider simpler solutions, the deployment of something that maybe through mass production gets, through scaling gets cheaper in the end, and that's not just high end. How do you see that? Maybe
Thanks.
difficult for Infineon, sorry.
No, not difficult. I'm just sorting my thoughts, but I will place, I think, 3 very important messages. The first one, as you know, I'm from electronics, artificial intelligence, and I was triggered by many, many words: sensors, perception, data fusion, all those things. We feel confident when we know what's going on outside. And this is why we are developing technology in the sensor fusion domain to transfer this know-how to the vehicle. And I really like the examples you placed, because you mentioned different operational design domains. And what is good enough is, for me, not the really question. The really question is, we have to understand our limitations. Then it perfectly fits to your question. If we are fully aware, okay, where are our limits? We can always be much more safer than if we don't know the limits, because everyone is talking about monitoring, predictive maintenance and stuff like this. This is all based that we know some kind of limits to be safe operating in an open context, to be honest, because every country, every road condition, whatever is different. And sensors are very key element for the future, where I also want to place another message for the key enabling technologies. I think sensor development goes also hand in hand with material science, especially if we want to make this energy consumption less. We have to think about, are we using the best materials today, or can we improve also from that side? So many challenges are there, but safe is safe enough is strongly related to understanding their own limits of the sensors. This is, for me, very key. I hope this answers some of your questions.
Yes, definitely. And it may raise some new questions, but I think we'll pose them in the break, just to not to put you too much on the spot and to make it also different. Anyway, thank you very much. I think we discussed already a bit on what could we get from key enabling technologies, or how could we get them from other sectors. But if we turn the question around, what could other sectors learn or use from key enabling technologies from CCAM? What do you think that would be? Which sectors could benefit? Selim, can I start with you?
Yes. Yeah, good question. Well, the other sectors that can benefit. So I said already aerospace is a potential area where we can consider cross collaborations between CCAM and perhaps aerospace systems. Yeah, aerospace has very good way of analyzing safety. And I think from CCAM side, we can benefit from their approach. And from CCAM side, I would say there's a much more complicated system solution and analysis, which can feed back to the future aerospace systems. And we are also looking into now smaller air systems, and we can expect a much more crowded airspace in different layers. So maybe this can feed into, from CCAM side to the aerospace domain in this context. Just as an example.
Thank you, very nice example.
Yeah, thank you.
One thing that I'm observing now more and more is the defense sector. I mean, for obvious reasons, that there's a lot of demand. And I do observe that, including quite some of the startups in Silicon Valley and beyond, that used to focus really on their software approach towards self-driving automobiles, that now gets a lot of requests from the defense sector. Also because they're getting fewer requests from the automotive sector, also for obvious reasons. So this is quite interesting how the automotive and the defense sector seem to be benefiting from one another.
Thank you. Those are already 2 nice examples. I think there will be more, but it might be taking too much time, right? to dive into all examples.
I was close to asking a Spanish question about the Tesla robots, but okay.
Yeah, but we'll save that for the break, because I have another question, because we also wanted to see a bit on how key enabling technologies for CCAM can help to unlock societal benefits. And if we look at that, what do you think we should do? Should we look mostly at connected cooperative approaches, or merely on the standalone vehicle approaches? And why? Oyana, I see you nodding already, so you get the turn first.
So I would say that I would not frame the question like one against or one against the other, or that we should choose one. I think that the wisest way to go further is the collaboration of both. Saying that, so it's true that this is the way of ensuring the societal benefit and the acceptance of the system. Truly knowing that vehicles should ensure the functionality also when it's under a critical situation, or when we have some kind of issues where connectivity might not be in. So the vehicle should be able to deal with this situation. This is something that is not negotiable. This is the basis. But said that, I would say that the connectivity, and especially not connectivity, the cooperative parts that comes with the connectivity, is something that is not an extra, it's not an optional, it's an enabling thing that enhance the perception, the decision making, the traffic management is an extra sensor. So let's take advantage of both, knowing that it's not one or the other, is about ensuring that the whole system is safe enough and is able to deal with the situation in every single situation, and make the advantage of combining both when they are available.
Georg, do you agree? Then we have a very simple answer, or have you?
Yes. In principle, yes. I think it's not negotiable that we want to deliver cars which can operate under various operating conditions. If there is a cooperation available, if there is connectivity, if there is 5G, whatever. It's again always a question of understanding their own limits. So when I don't have this, I have to survive anyhow. It's not an option to make a safe stop, maybe here outside, and that's it. So it's always a question what I'm able to do. And if I have this additional enabling technology available, I can do better than without it. That's no question. So that's for me the way of thinking, that we always have the boundaries in our face, because it's also a very important topic for society, for acceptance and so on. So if the system knows where are the limits, don't take any risk which is not necessary, then this will also push user acceptance and all the connected topics.
Before we turn to the next Menti question, so let's keep this for a second. I'd like to. We need to actually switch our minds a little bit towards another aspect of enabling technologies, and that is what the usage and application means for the development process, and for the speed of it, for the robustness of it. And in order to get us all into that new mindset, I'd like to ask again the two people who mentioned software-defined vehicles in that presentation, and that was Oyana and Georg, to briefly tell us what you believe is the effect of this enabling technologies on the speed of the development process, or the robustness of the development process. Does it help, or does it make it more sophisticated, more unreliable, things like that? Oyana, I think you have an opinion about that.
Yes, so I think that the coupling software and hardware is a major enabler for ensuring faster innovation, as I mentioned before. So, and also enables let's say the scalability and allows us to deploy in another in a faster cycles, because we are decoupling the hardware and the software, so we are enabling the life cycle of the software, meeting not with the limitation of the hardware. But when doing this, I think that Georg already mentioned that we are opening another door for ensuring how we are going to be doing these uploads or these upgrades of the software on the same hardware. It's not the same dealing with decoupling hardware and software and making updates on a non-critical system and in a critical system. So it's faster development, but we need to be very clear on what are the extra things that we need to take into account. So we need to ensure the safety. If we are going to be uploading and doing uploads of this software, we need to take into account safety validation, certification, and how we are going to do and to close this cycle. So it's faster, but we need to take into account and take care of other extra things that for the moment we are not taking into account. And I think that Georg mentioned that in his presentation. So.
Yeah, Georg. So I'm a bit afraid of beta versions on the car all the time. So to talk a little bit more about the extra things. But Georg, what do you think?
Yes, very good question. And I want to connect once again to the life cycle, what I've shown in the introduction. I think there are so many potentials, as you mentioned, Gerion, but we can only enable them if we really live in that life cycle, what we are proposing. So I can observe many times that there are lots of activities, but no one lives in the life cycle really up to now. They live in the old style automotive supplier value chain, but this is not the reality anymore. So we have to think about the new roles in this life cycle that we can all work together in an efficient manner. Just to give you an example, when we, for example, see a deployment running, only the vehicle operator or the OEM or whatever has all the data and doesn't share it back to the sensor developers, for example. So we cannot improve without being disconnected in that value chain. That's something we examined quite often, and we have to think about how can we rearrange the new value chain which fits to the life cycle, and then I see many activities in terms of efficiency improvement, energy improvement, data sharing. We have to think about so many topics together in parallel to really enable what we are putting as our objectives on our table.
I'm curious to learn about Selim's and also Sven's opinion about this. In the meanwhile, I think we could bring up the next slide, though, if possible. I don't know whether you want to do it again with the browser, I guess. And the question that we are asking is a twofold question. And it is the technology development processes using EUCAD, such as SDV, AI, robotics, and others. The question is, do they lead to faster or slower development process? Do they lead to more or less robust development processes? So we please answer that in the slide or in the meanwhile. Any other opinions about this matter, whether related to SDV or in general to enabling technologies, Selim or Sven?
Yeah, maybe I can mention that the viewpoints of our colleagues that commented on this is totally valid, so I fully agree with them. Yeah, I can also add to that, yeah, there are many different key enabling technologies, and their effect can significantly affect the performance of the software-defined vehicle. In the end, we need to be able to answer the safety question. So this was also mentioned by Sven earlier. So if we can ensure that this is safe enough, taking into account these new technologies, disruptive technologies, would be, of course, beneficial for the future software-defined vehicles. Yeah. So, but yeah.
Sven, any reflection?
Yeah, let's see. So I'm not sure if I have an answer to your question, whether because of the software-defined vehicles and also all these key enabling technologies, the vehicle development process gets faster. So I would have a hard time to see a situation where we're having relatively complex technology like AI and LiDAR sensors and communication connectivity technology now all integrated into the car. And by the way, it's going to be faster to develop. I have a hard time seeing that. In general, yes, you might say that to develop and even more to prototype and test software is probably faster than hardware, but you will still need hardware. And wherever you put the emphasis, so you can debate what is faster or slower. So I would definitely say for sure, and that is not in order to dodge your question, it's actually to have us all think about it. The vehicle development or the automotive development process changes because in a way it gets longer. It's actually being dragged into the deployment and usage of the vehicle. As you said, you don't want a world where there's a lot of better products that we are basically testing as consumers. But the idea of the software-defined vehicles, among other things, is that you can further develop and add features during the life cycle of the vehicle that Georg actually showed in the presentation. And that is a changing development process, that it's not during the lifetime of the vehicle you fix a few things here and there, and hopefully not through recalls, but through more subtle updates maybe that you provide to the consumer. Now you can actually add new features during the development because it's easier with software than it might be with replacing hardware. So I think the automotive industry, because of these key enabling technologies and the software-defined world, needs an upgrade to the development process. Whether that's going to be faster in the end, we'll see.
Sounds still a bit like beta, but okay. At the same time, okay, we learned that, for example, collecting data for validation during operation is an opportunity and can accelerate the process. Shall we bring up the
we shall bring up the results.
And see what people in the room think, right?
If we convince people or they look differently, yes, let's see the results. So, the CCAM technology development process using new key enabling technologies is going to be faster, says the majority.
These are all tech people, and they, of course, believe that they can deliver within 3 years project.
But we do realize, of course, that with a yes or no answer or a faster or slower answer, you have not too much room for nuance, what you did have. Do you want to add something to this, what you see now? Or I think, Sven, you already meant something there. Any of the others? Selim?
Yeah, maybe I can comment. Yeah, it's an interesting answer. So I also think, like Sven, that I don't know if it is going to be faster or slower, but we know that it's going to be complexer, the newer system. So in order to make it faster, the validation and verification need to adapt to it. Yeah. So if we can find very good methods, approaches to ensure this, then yeah, we can make it faster. Yeah. Okay. But it's good that there's an optimism here.
Good, thank you. And let's also look at the other one, the robustness. Do we think it's going to be more or less robust? Ooh, spooky. Either no one did fill the question or... Ooh. Oh, so yeah, I was not too far off, I guess.
Oh,
it's live voting, really?
This is fun.
So either the connectivity is a bit low and the results are coming in a bit late, or I'm not sure. So good, maybe less robust. Oyana, how do you see this? I see you look a bit puzzled, right?
Yes, to be honest. So I think that as we have mentioned when we were analyzing the previous Mentimeter, when telling which is the key enabling technology that we give for granted in order to ensure that the future vehicles or automated vehicles are going to be deployed, has been the AI, okay? So now as telling that the AI and having this question and saying that it's going to be less robust than the current vehicle, that's why I'm puzzled, because I think that without the AI, it's not going to be able to deploy or to meet the promises of having automated driving. But if we don't believe that with the AI and with the effort that we are doing for building trustworthy AI, because at the end we need to ensure that we know what the vehicle is doing, although we are including AI, that we and the people here is technical people, we don't believe that the AI is going to be robust, and this puzzles me a little bit.
And Sven as well, I see. And how about you, Georg?
Yes, very tricky. I think both questions should have the top goal to be faster and more robust. But when this top goal will be reached, I think that's the big uncertainty. And this uncertainty is also reflected from my point of view in that graph here. So there are so many uncertainties that we are not super confident that it will be more robust because we don't know how to execute this new development process in an efficient manner. But I think if we do this once, we do a successful deployment, when we also take a look to US and so on, I think what we can learn there has an incredible impact to do it better in the next iteration. Not just the data, because AI without data, it's questionable, and then I understand this result. But I think the uncertainty, we have to get rid of the uncertainty to have a more clear picture here.
Thank you. And maybe, of course, if we still have uncertainty amongst peers, what happens if you link that to what happens with other citizens who don't know too much about the technology? Would the graph be totally different or exactly the same? That's a question we can't answer right now, but we're biased. So you go to
yeah,
the next.
but a question we may be able to answer is if we dig a little bit deeper into what we are more familiar with, and that's the automotive development process. In order to understand where these features of speed and robustness may interfere and how they are influenced by new trends, and maybe let's pick software-related, AI-related perspective here again. In my Mickey Mouse world, a vehicle development process is something like this. It starts with like setting the requirements, then planning the process, and then all the development teams disappear for 2.5 years in their labs, and they come up with the solutions. And at the end, everything is integrated, and of course it works, and it's a fabulous product. And if not, you have to restart this, and it takes a while to improve, I guess. So my question is there anything we can learn in terms of agility or acceptance of solutions that develop over the time of the usage that we can learn from software development, for example? And I think the person that is closest to software development here is Oyana, right? So you would be interested in knowing that.
So yeah, it's a tricky question, because as you mentioned, and we have already been mentioned a couple of times here, is the development cycle, and how we should adapt this development cycle that we are usually we are familiar in the automotive sector, and we need to adapt that to more flexible and software oriented, which is tricky because it's not just doing a B cycle where you come with the requirements, you leave and you check and start again. It's about enabling some kind of more flexible approaches to test and validate in between to give you more flexibility in the adoption of software and inclusion in software on the sector, which might and is changing a little bit the value chain of the whole sector, and it's also impacting on the skills and professionals that this sector is demanding, which is also a tricky thing to be integrating and bringing those people that are coming from another sector to a sector where the regulation and where the requirements are very strictly handled. So tricky question what you were asking here.
My perception is that there's regions of the world that seem to be a bit more relaxed on the restrictions of this, and seem to be implementing those agile development processes faster. What are they doing differently? Any opinions about Sven, please?
I can maybe talk a little bit about it from the Silicon Valley perspective. And first of all, Gerion, I find it interesting that you describe it as a Mickey Mouse world of yours. So I'd be curious to hear more about your Charlie Brown world, what's happening there. You might enlighten us with this. But it is quite interesting when I talk to people in Silicon Valley about Agile and Scrum and all of these things, and that visitors from Europe want to have a conversation, how does Agile work and what can we learn from it and so on. And quite often people in Silicon Valley roll back their eyes like, oh my God, this thing again. It's not that everybody embraces like these methodologies. And then what they do say is, well, look, Agile works well for software development. And this is where you really have these fast iteration cycles, innovation sprints, and then you come back and huddle and you get your next ticket and things like that. That doesn't work so well for hardware. And the reason being because prototyping is inherently, I don't know, more complex, slower, whatever you want to call it. I mean, to come up with a new hardware just takes time, even if it's 3D printing. It doesn't go as fast as software development. So instead of trying to copy a process and hope that it applies for a software and hardware product that an automobile inherently is, really think about what can I take from it and how can I further evolve it. I think that's what we need to do here. So not just copy like an agile process and they're our Scrum masters and then we're all Silicon Valley cool and fast. Evolve it. I think that's what's needed.
Yeah, you were talking about isn't it? And how is this? Can this be implemented?
Yes, you mentioned with your Mickey Mouse world a very tricky question. But I can give you maybe a concrete example. I try to make it really concrete. When we were in the world where functional safety was enough, there exactly this happened. So, and the norms or the standards are really important for the companies because teams are built around those norms that they can do this, implement it efficiently, the V model and all the stuff like this. But now the situation changes, especially with artificial intelligence. We have new software norms, we have new standards, we have the European AI Act, we have to do this and that, but the standards how to implement this are missing or currently under development. And the critical thing from my point of view is multiple standards are developed in parallel without interacting to each other in a correct manner. But at the end, they have to fit together to make a product trustworthy and user acceptance for being compliant for the AI Act. And that's the tricky thing. So again, here, the uncertainty, I think, is a big blocking factor in our heads to implement the process as efficient as we were used it in the previous times. And this is, for example, the case for, maybe the ISO 8800. The path, it's now the first released and will be further developed and has a huge impact on the teams, on the company structure, on how to implement this. And how can it fit together with the old style ISO 26262? We have the SOTIF, the 21448, and so on. So we are struggling at the moment to bring this together.
Maybe, Selim, you guys might have an answer. I mean, these are the smartest software and electronics developers in Europe at Virtual Data. So,
yeah, thank you for the nice comment. I'm not a software developer myself, but I work with a lot of software developers. For me, software is for prototyping, so I'm not a production code developer. But I can refer to a fact. So we know that the current vehicles are mostly very big, large robots with a lot of code, right? So they depend a lot on software. So we cannot really describe or think about vehicle development process without the software development process. So we need to take this into account. And last year I was at a conference in Graz, so it's called Zukunftstag, organized by UNM Research. There, a keynote speaker from TU Munich, so a computer science professor, she mentioned an interesting fact. She said that nowadays, most of the production code written by professional developers, the most
Yeah, it's back on. Woohoo! So safety is a very obvious one. Efficiency, connecting to the rural transport system, uninterrupted ODDs, which is of course still a huge challenge so far.
So does this reflect actually how often an answer is given?
Yes.
The bigger it
broader
is,
word.
the more often. Yeah. The color is just for the nice. Public transport, sustainability. I think Sven, that hint might have worked, or it was there before. I don't know. Availability, yes. So, any responses, Selim? How do you see these inputs?
Yeah, I think it's pretty much distributed. Sustainability and safety seems to be the most relevant according to the audience. But I would say, yeah, societal demands, safety is of course quite important, but end user acceptance is also quite important. So the fact that it's safe doesn't mean that it is going to be used and utilized by the end users. I was talking to Torsten, so one of our project colleagues, yesterday, and he mentioned that he has some experience with truck drivers and new truck with a lot of assistance systems. The first thing that the drivers do is to switch off all the safety systems because they don't think they're useful and they make their work difficult, so they switch them off. Is this really what we want? So we need to ensure that the developed systems are trustworthy, in addition to being safe, and they're able to be used, understood, and used by the drivers. That's very important.
Here's the other question. Or the results.
And the answers, yes. Let's bring them up.
Maybe this is live again.
It's like no one did answer this one. Yeah, there is a 0.
They're not relevant.
Really? Was this too challenging? Are we speaking so much faster than you can type? 0 answers. So
Look,
we need another session. Oh.
What we do is we collect ideas from 3-4 people in the room, yeah?
Yeah.
Very quickly. Here they are. Menti is very slow. So there we have another example of speed and reliability, digitalization, AI, cybersecurity of being of particular relevance for meeting societal needs, data sharing ecosystems, digitalization, AI, machine learning, robustness, certainly from a consumer's, a user's perspective, super relevant. I also always find technologies that could serve the needs of people that have particular special needs is, I believe, also an important opportunity that we are having using AI, for example, using robotics, using software. Trustworthiness is mentioned here. Price of sensors out. These matters come in, yeah, with cost and reliability. Yeah?
Sorry, I think someone's ready for a break, filling in steam engines. I'm not, yeah.
I was going to ask, who put in steam engines?
Steam it? What? Where's steam?
But thanks for that. But yeah, maybe in the break, just let us know. Well, maybe that means that there's someone having a burning question. Shall we ask?
We could definitely ask people in the room, 2, 3, to raise their
Any burning
comments or-
questions?
Yeah. Any questions for this panel on this matter, on the things we are just discussing? Any comments you'd like to make?
Yeah, you're on an odd row, so you have a microphone connected to your chair. That's a nice system.
Yeah,
you
it
do.
is.
Yeah. On your right-hand side. There might be. Yeah, there is.
Yeah.
Fancy room, isn't it? It did this morning. We tried. Everyone.
No, it does not, but there is no other mic, so please.
Testing.
Yeah.
Yeah.
Success. We have liftoff. Fantastic. I kind of liked Sven's comparison between what is driving this development in different territories. You know, new business models in the US and societal benefit in Europe coming through. And I wondered, does that also reflect our attitude towards data sharing? I mean, I've picked up, you mentioned one OEM in the US, I've picked up that court cases have demanded that they release data, you know, and driving incidents and camera footage, and they have refused to do that. Whereas in Europe, we're talking more about federated data platforms and sharing that. So does the societal readiness have a perspective on data sharing? And I think it was also mentioned about feeding data back to the developers of the sensors as well. So it's a question across a few panel members, but particularly on that different aspects.
Very much appreciated. Thank you. Anybody in the...
Yeah, let's see. I definitely see it as a cultural difference. So industry culture, if you want to call it that. That in the US, I would say one is even more protective regarding corporate data or testing data that you might be in Europe or other parts of the world for that matter. I mean, it doesn't mean that everybody's just freely sharing the data here in Europe. But in the US, particularly in Silicon Valley, the West Coast, data is being seen as a huge asset. And let me then add, they also know what to do with it. Whereas here in Europe, I observe more an attitude, oh, data is the new oil, data is important, but what do we do with it? So there's a difference there for sure.
Any further comments on this from the panel? Okay, then we ask, is there further questions? Please, over there. Yeah, try it. It will work.
It's already on. Okay, thank you. Ella Peltonen from University of Oulu in Finland. European sovereignty on data, computing, electricity, and even the electronics is now a big thing. So how do you see what's the future with the CCM services on considering the sovereignty? Are we here also dependent on the American and Chinese and other sources, and if you are in which level, and how big is the problem? So if you make all the cars very clever and smart, and then we stop having some service, for example, from the cloud companies, what do we do?
If I wish you should answer the question.
Anyone?
Then I would probably ask Georg to.
Yes, very tricky question, as I think everyone knows in the room. I think it's also maybe one point, a strong question of regulation. So we have the European Data Act, the AI Act, we have GDPR, we have this. And I think to bring everything under one head and to structure all the developments and bring everything together is a huge challenge at the moment. But I still have the hope if we went through this process once successfully, I think we can then also profit on a long term with putting our European sovereignty in front. Then we have the excellence in place, hopefully with some iterations, very realistic. So the regulations will be adopted in the future, iterated, because they were developed very, very fast under a lot of time pressure. And what I mentioned before, the related standards, how to implement this on a company level, are not ready yet. And this also triggers some iterations. But on a long time, I'm very confident. At the moment, it's very tricky. I think it's also a question. We should think about it if we can do this together to sort out this puzzle of, I would say, interconnections in an efficient way.
Yeah, I'm nodding. So I guess there is agreement in the panel on this. Unfortunately, our time is up, so we can just summarize very briefly. So we heard our panelists talk about particular perspectives on key enabling technologies to enable CCAM in the future to further progress it. We saw Ujana talk about some fundamentals in integrating CADs into like AI into CCAM. She also talked about software-defined vehicle and the role of that in this context, referring to the Cluster 5 in the CCAM partnership, which is on enabling technologies. By the way, this session is co-organized with Cluster 2. We have the two cluster leads Oyana and Margriet here for Cluster 5, but also David Storer and also myself, we are leading Cluster 2 vehicle technology, so there's close collaboration there. We heard Georg talking about version 0 of software-defined vehicles, as he called it. And so there's a lot of room for further development. We understand and we understood a bit better maybe how these concepts of decoupling and co-design interrelate. And that's a very important point, I believe. Then we saw Selim bringing in the perspective of validation, verification, saying also that certifiable, upgradable, cyber-secure systems are of relevance for societal readiness. And we saw Sven widening the scope beyond Europe and making us aware that CCAM is a European concept and that people in the US would rather talk about CAV, so connected automated vehicles, in Asia about intelligent connected vehicles. So also the point of where the intelligence actually is, whether it's rather in the infrastructure or rather in the vehicle, it's a different one. We, in a sense, are aiming at a more mixed approach here in Europe. Then we had quite some discussions involving you through the Menti. We saw a lot of proposals for CADs of relevance, whether that's quantum cloud, cybersecurity, AI, SDV. We discussed about speed and reliability and robustness of the development process. And we also looked into the push-pull relation of technology development, understanding that safety is an important societal perspective to be considered. Cybersecurity is something that we can expect enabling technologies to better deliver in the future. Well, we could probably repeat even more of that. You have all your experiences and your thoughts in your minds. Hopefully we could trigger a little bit of that. With this, I could just thank our panelists, Oyana, Georg, Selim, Sven, our co-organizers and rapporteurs of the session, Hélène Correal and David Storer, Margriet.
And thank you, Gerion. Thank you, and see you later today. Thank you.